What's up, Simps Army? Got a great in-class vid right now. I think this stoic packet lends itself very well to a video that you guys can control, pause, rewind, watch over and over again, and just have something to go back to when doing the other examples. So what I'm going to do is the first example in this packet. What are we talking about here? This is stoichiometric conversions between grams given to grams needed. What does that mean? It means that if we look at our island here, we have our two substances, substance A, substance B. We're starting here with the mass of one. We're going to go to moles of one. From there, we can go to moles of another one. And from there, we can go to grams of that one. Okay, so it's grams to grams, but to get there, we have to go through this process. All right, that's what we're talking about here. Here is the plan per se, going from grams to moles to grams. So it's step-by-step process, and you have to take it step-by-step, otherwise it gets overwhelming. So each arrow is a conversion factor, what I just underlined up here. So you're given an atomic or molar mass. Now this just means whether it's a single element or a molecule. You're given that. You have to get the ratio, so the number of moles of A to the number moles B, whatever that ratio may be. And then we get to our atomic or molar mass of B, which is what we need. So this is what we're given, this is what we use, and this is what we need. Okay, and then this is always going to be changing for different elements and formulas, et cetera, et cetera. Okay, so here is the first step of the packet, and you can see the links to the video from the lovely Mrs. Rogers Miss Rogers from last year. If you like her better than me, by all means, watch her stuff instead of mine. So our first step is we need to balance this equation, because in order to get the proper ratio of moles, we have to have a balanced equation. So that's a first step in a lot of chemical endeavors. So let's do that. Let's look at what we have here. So on our reactant side, we have hydrogen, and then we have sulfate. So let's take a look here. SO4, and over here it's still SO4. So that means I can treat that as a separate single unit in my balancing. Okay, SO4, then I have sodium, and then I have hydroxide, OH. So then I look over on my reactant side and I see that that OH doesn't stay together as OH. I have a hydrogen and oxygen here. So I can't keep OH the same on both sides. I have to break it up. But I already wrote hydrogen out, so I put another oxygen here. And you might notice that I have oxygen and sulfate and also oxygen separately. That's okay, because sulfate is a unit on its own, and I need oxygen to be separate. So then I write the same out over here, HSO4, sodium, and oxygen. Okay, and I'm gonna get my numbers here. So I have 2 hydrogens, I have 1 sulfate, 1 sodium, and then I have, I have 3 hydrogens, my fault, hopefully you caught that. And then I have 1 oxygen outside of the sulfate. Now over here, I have 2 hydrogens, I have 1 sulfate, 2 sodiums, and again, 1 oxygen outside of my sulfate. Okay, so let's look at what we can do here. Well, hydrogen I have in multiple places on both sides, so I'm gonna pause on that one for a second. I'm gonna move on. SO4 is balanced right now. Then we get sodium. So let's try to balance sodium. So I'm gonna slap a 2 down here. That's gonna balance my sodium for now. I also just affected oxygen. Now I have 2 oxygens, and I just turned hydrogen into 4 instead of 3. Okay, so now let's take a look at oxygen. I want 2, so I'm going to put 2 out here. Now I have 2 oxygens, and I also just changed my hydrogens. Now I have 4 hydrogens, and we're looking good. We got 4 hydrogens on each side, 1 sulfate, 2 sodiums, and 2 oxygens. So this is balanced. So up here, do step 1 is where I'm going to write my balance equation. So I have H2SO4 plus 2 NaOH going to 2H2O and 1 sodium sulfate. Okay, so now you can start to see why balancing equation is so crucial. This gives us our molar ratio, which we're going to need later on. All right, so now we go down to the next thing, identifying our known, unknown, and conversion factors. This unknown here is weird, ignore that. Your handout might say needed, which makes more sense. So our known, unknown, and our conversion factors. So we go back up here and let's look at what we're given. How many grams of water are produced if, oh geez, oh dear Lord. Okay, that scared me. I was watching a movie and I paused it, and I guess I'm not allowed to pause it anymore. That stinks. I want to go back to watching this. How do I pause it? Okay, it's paused. Oh, it unpaused. All right. Let's see. Okay, whatever. This is more important. Okay, so anyway, how many grams of water are produced if 2.0 grams sodium sulfate are produced? Okay, so I probably should have read that first before I even went into balancing, but that's what we're looking at here. So we have H2SO4 and sodium hydroxide going to producing water and sodium sulfate. Okay, so now we go down to our known. What is our known? Well, that's what we're given. So we're given that we have 2.0 grams of sodium sulfate, Na2SO4. Okay, that is our given. What's our unknown? What do we need? What are we trying to find? We're trying to find how many grams of water are produced. So how many grams of H2O are produced? Okay, so now we got to find our conversion factors. The first thing that we need to figure out is the molar mass of our known, the molar mass of what we're given. So that's Na2SO4. All right, so we have sodium, we have 2 sodiums, and that is a molar mass of 22.99. We have sulfur once, which has a mass of 32.06. And we have oxygen 4 times, and I'll do the mass of that, 15.99. Again, if you use 16 or something slightly different, it's not going to really change your answer that much. Okay, so this gives me 45.98. This gives me 32.06. And this gives me 63.96. And I add them all up to get 142 grams per mole, aka 142 grams of Na2SO4 per every 1 mole of Na2SO4. Okay, I kind of encroached upon my molar ratio area there. That's okay. So the molar ratio, we're going to use our balanced equation to find that. So we're trying to figure out how many moles of Na2SO4 for every mole of water. Okay, so we use our ratio out here. So we have our coefficients 2, and then there's nothing here, which means there's a 1 here, right? So for every, I'll just do this in a different color so that there's a clear, somewhat clear difference. So for every 1 mole of Na2SO4, I have 2 moles of H2O. Again, I got that by using the coefficients in my formula, 2 and 1, 2 to 1 ratio. So there's 1 mole of Na2SO4 for every 2 moles of water. And I'll highlight my other conversion factor down here. Okay, and now we're going to go to the molar mass of water, which might become second nature to you guys at some point to know that. So we have hydrogen twice, and that's 1.01. Then we have oxygen once, and it's 15.99. So we get 2.02, 15.99. So we get 18.01 grams per mole, aka 18.01 grams of water per every 1 mole of water. Okay, so now we have our 3 conversion factors. We have our conversion factor for the molar mass of our known, we have our conversion factor for the ratio, and we have our conversion factor for the molar mass of the unknown, what we need, what we're trying to find. So if we go back up to here, we have, so we just found the molar mass of our known so that we can go from here to here. We found the mole ratio so we can go from here to here. And we found the molar mass of the unknown so we can go from here to here. And that's going to allow us to solve what we need to solve. Okay, so now here is a very organized breakdown of what we're doing in our conversions. So we need to change our known, which is in grams, to moles using the molar mass. Okay, so we are given that we have 2.0 grams of Na2SO4. We're given that. Okay, that's our given. Normally you see me just write that out alone. In this case, I'm going to put it over 1. Okay, so it's just what it is. It's a great explanation for something. It's just what it is. Okay, so our conversion factor now is going to be this one right here, so that we can go from grams to moles of Na2SO4. So I need to cancel out grams, so I need to drop it like it's hot. I know that grams of Na2SO4 is going to be down here. So I look at my conversion factor, it's 142 grams of Na2SO4 for every 1 mole. Okay, so in my first conversion factor, I'm going to be canceling grams, and I'm going to be left with moles. Okay, so now that I'm left with moles, I use my mole ratio to convert it into moles of water. So I'm going, now I went from grams, we re-reference this, I just went from grams of Na2SO4 to moles of Na2SO4. My next step is to take those moles of Na2SO4 and convert them to moles of water. So in this case, this is all this, and this is this. So now I'm going from moles to moles. And to do that, I'll use the mole ratio that I found from my balanced equation. Okay, so again, I am trying to cancel moles of Na2SO4, so I know that's going to be dropped like it's hot. It's going to go down here. All right, and if I look up at my conversion factor, that is 1 mole of Na2SO4 for every 2 moles of water. 2 moles of H2O. So I canceled my moles of Na2SO4, and now I'm in moles of water. So now we're here, and our next step is to go here to our final answer, which is mass of H2O. Okay, so now we can go to mass of H2O using this conversion factor. Okay, so moles of H2O is what we're canceling this time because we want to end up in grams. So I know moles of H2O is going to be down here. And I know that for every 1 mole, I have 18.01 grams. 18.01 grams of H2O. All right, so the final thing I canceled was moles of H2O. My moles of H2O are gone, and I'm just left with grams of H2O. All right, so now this math, you're going to do 2 times 1 times 2 times 18.01. So you're going to get 18.01. Or I'm sorry, you're not going to get 18.01. You are going to get, would be 2 times 2. Let me do this real quick. I don't want to skip this and just say do the calculations, but you multiply all the numerators together. So then you get, still an eraser. I'm going to do a brighter color so it's easier to see. So you get 72.04. I'm sorry for this technical difficulty. I'm just going to do this out here. You get 72.04, okay, divided by 1 times 142, divided by 142. Okay, okay, because I just have 1 times 142 times 1 times 1. Okay, and that's going to leave me with my answer that I got is 0.50732, and it keeps going on. So significant figures. Let's look. Now here I was given 2, here I have 3, and here I have 4. And these ones, the single digits for moles, like I said, if you say 100 pennies, they're all significant because you're talking about an exact thing. I don't know if that's a proper way to phrase that, but anyway, you don't include those in your significant figure consideration. So it's 2. I'm just going to keep 2. So it's going to become 0.51 grams of H2O. Now in this fraction up here, I could have written all the units that combine and all the units that combine here, but we know that we canceled as we went and ended up just with grams of H2O. So my final answer is 0.51 grams of water. I started with grams of Na2SO4, and again, one more time, you're probably sick of hearing this, I went here to moles, moles to moles, and moles to grams. So this is a conversion we do a lot in chemistry, and it just goes to show how you can go through this stoichiometry diagram in a bunch of different ways. So hopefully that made sense. Now you can jump into attempting the other ones on your own, and I will post answers to those at some point. So give them a shot. Gram to gram conversions, great stuff. Getting into some real chemistry. It's exciting. I'm excited. I'm excited for you guys. Chemistry takes a lot of foundational knowledge, which we've been doing a lot of, and now we're really getting into reactions and calculating different things and stuff that's exciting and awesome. So thank you guys for watching. Thank you for working hard, and keep